Hey, I'm Alice. Welcome to Facts That Surprise Even the Smartest Among Us. Today's question is one of those rare ones that seems like it has to be wrong, until you realize science has a strange sense of humor. Why do hot water and cold water freeze at different rates? More specifically, why does boiling water sometimes freeze faster than cold water? To help me untangle this icy mystery, I invited the one and only Smarty.
I am Smarty. And yes, Alice, this one is as weird as it gets. It's called the Mpemba Effect, and it's one of the most surprising observations in physics. The basic idea is this. Under certain conditions, hot water can freeze faster than cold water. Sounds impossible, right? But it's real, and it's been puzzling scientists for decades.
Okay, wait, what? Hot water freezing faster than cold? That goes against everything we learned in school.
Exactly, and that's why this effect got so much attention. Think about it. If you have two identical containers, one with boiling water and one with cold water, and you put them both in the freezer at the same time, you'd expect the cold one to freeze first. But sometimes, the hot one beats it to the finish line.
That just sounds wrong. Who figured this out?
Great question. The effect is named after Erasto Mpemba, a Tanzanian student who observed it back in the 1960s while making ice cream in school. He noticed that hot milk froze faster than cold milk, and when he brought it up to his teachers, they laughed at him.
Oh no! Don't tell me this is one of those "the teacher was wrong" stories.
Oh yes! Mpemba stuck to his observations and eventually worked with a physicist named Dennis Osborne, who helped him test the phenomenon more rigorously. In 1969, they published a paper confirming that under certain conditions, hot water really can freeze faster than cold water.
So the effect is real. But do we know why it happens?
That's the juicy part. We're still debating it. There isn't one simple explanation that covers every instance of the Mpemba effect, but there are several plausible theories, and they're fascinating.
Hit me with them. Give me the short list.
You got it. Theory number 1, evaporation. Hot water evaporates faster, so there's less of it to freeze. Less water means faster freezing.
Okay, that makes sense. Smaller volume, less freezing time.
Exactly. Theory 2, convection currents. Hot water has more dynamic movement, creating stronger currents inside the container. This movement helps the water lose heat more quickly.
So the water cools faster because it's more active?
Right. Then there's theory 3, dissolved gases. Hot water has fewer dissolved gases like oxygen and carbon dioxide. These gases might interfere with the freezing process, so less gas could mean faster freezing.
Interesting. So the chemistry of the water changes?
In subtle ways, yes. There's also the idea of supercooling. Sometimes, very pure cold water can cool below freezing without turning to ice. It just sits there, waiting for something to trigger the ice crystals. Hot water may skip this phase and begin freezing more normally.
So in a weird way, cold water can stay liquid too well?
Pretty much! It's like the water is being too polite, waiting for the right moment to freeze. Meanwhile, the hot water is like, let's get this over with!
I love that image. Boiling water with attitude.
Right? Now, one thing to keep in mind is that the Mpemba effect doesn't happen every time. You need specific conditions: the shape of the container, the temperature of the freezer, humidity levels, and even the type of water can influence the result.
So if I try this at home, it might not work?
It might, and it might not. That's part of what makes it so interesting. It's not a guaranteed effect, which is also why it was controversial for so long.
Okay, so let's say I want to test it. What would I do?
Simple setup. Take two identical containers. Fill one with hot tap water, around 80 to 90 degrees Celsius, and the other with cold tap water, around 20 degrees Celsius. Place both in the same freezer and observe. Try to make sure the containers have the same shape, material, and are placed equally in the freezer.
And then I just wait?
Yep. Record the temperature over time, and you may notice that the hot one freezes first. But be ready for the opposite too. Science can be moody.
I love that. Science can be moody. So true.
Another fun twist? Some scientists think that thermal conductivity of the container and surrounding air circulation might play a big role. A hot container might melt frost underneath, improving contact with the cooling surface and helping the heat transfer more quickly.
So the hot water gets a kind of fast track to losing heat?
Exactly. There are just so many variables in play that no one explanation covers all scenarios. That's why it's still actively studied today.
Has this been used in any real-world applications?
Not really in industry, but it's great in science education. It challenges students to think critically, question assumptions, and appreciate how even simple observations can lead to big questions.
And it's a reminder that science isn't always neat and tidy.
Right. Sometimes science is messy, confusing, and full of surprises, and that's exactly what makes it fun.
So let me see if I've got this. Under certain conditions, hot water can freeze faster than cold water. It's called the Mpemba Effect, and it's influenced by things like evaporation, convection, gas content, supercooling, and container dynamics. But we still don't fully understand it.
Perfect summary. And if that doesn't blow your mind just a little, try explaining it to someone else and watch their eyebrows raise.
I'm totally doing that tonight. Hey, did you know hot water can freeze faster than cold? Instant dinner table science.
You're welcome.
Thanks, Smarty. I think we all have a better understanding of how something as simple as freezing water can reveal just how complex our world really is.
Always a pleasure, Alice. Stay curious and never trust ice at first glance.
And to all our listeners, next time you make ice cubes, think twice about which water you pour in. Science might surprise you. Thanks for listening, and remember, the world is full of everyday mysteries waiting to be explored. Catch you next time.